Hello, today we're going to learn about inequalities. So, inequalities are a comparison of expressions that are not always equal. So, what does that mean? So, if I look at this first one here, I have x, and then I have this symbol, and then 5. That symbol means that x is less than 5. The opening of the symbol points to what's bigger. So, it's saying x is less than 5. All right, so we can show that on a number line, and the way we do that is I would put a circle over 5 because it says x is less than 5, and it shows that it's less than 5, so that means I would put an arrow pointing to the numbers that are less than 5. So x could be any number you can think of that's less than 5. It could be 4, 3, 2, 1, 0, -1, -7,000. It could be 3.5. Any number smaller than 5, x could be in this situation. All right, this next one down here, I have that same less than symbol, but then I have a line underneath of it. So when I have a line underneath of it, that means that this is less than or equal to. So that means x could be any number that's smaller than 5, but it could also be 5. Where this one up here, it cannot be 5. It's just any number that's less than 5. So the way we show the difference between this one and this one on a number line is we put a circle above 5, but to show that it could be 5 is we fill in that circle. And then it says less than, so we point the arrow towards the numbers that are less than. So less than or equal to 5 on a number line looks like this. The filled in circle shows that it could be 5, but it could also be any number that's smaller than it. All right, there's two more symbols we have to learn. So this one, I see the opening of this inequality symbol is towards the x. So that means that this is x is bigger than 5. Or another way of saying that is x is greater than 5. So the way we do that on a number line is we put an open circle over 5, and we put an arrow pointing to the numbers that are greater than that. It can be any number that's bigger than 5. It could be 6, 7, 8. It could be 6.5. It could be 5.5. It could be any number you can think of bigger than 5, but not 5. It has to be bigger than it. This next one down here has that same greater than symbol, but that line underneath. And that line underneath means that it's greater than or equal to. So what that means is it can be 5 and any number bigger than 5. So the way we show that is the same way. We're going to put that circle over 5, and then we're going to fill that circle in. That shows that it could be 5. And it can also be any number bigger than 5, so we draw an arrow pointing to the numbers that are bigger than 5. So this one, it could be 5, it could be 6, it could be 7, 8, any number bigger than 5 or equal to 5. All right, let's try two examples real quick. If you want to try this on your own, go ahead and pause the video and see if you can do this on your own, and then unpause it and see if you got it right. All right, so this first one, it says A is greater than 4. So I'm going to put 4 on my number line, and I'm going to put a number bigger than 4, and a number smaller than 4. And it says A is greater than 4, so I'm going to put a circle, and greater than means I'm going to put my arrow pointing towards the numbers that are bigger than 4. So which solutions are bigger than 4? Well, it can't be 4 because it's not equal to 4. But it could be 5, that's bigger than 4. It could be 6, that's bigger than 4. And it could be 7, that's bigger than 4. All right, what about this next one? It says D is less than or equal to 5. So I'm going to put 5 in the middle, put a number that's bigger than 5, and a number that's smaller than 5. And let's pick out which one. Oh, it's less than or equal to. So that means I'm going to put a circle above 5. And then I'm going to shade in my circle. And then it says less than, so I put my arrow pointing towards the numbers that are less than 5. So what answers are less than 5? -4 is less than 5, so that works. 0 is less than 5, that works. 5, it says less than or equal to 5, so that could be a solution. But 6 is greater than 5, so it can't be 6. So, inequalities have more than one solution. In fact, it says here, how many solutions does an inequality have? Inequalities, there's more than one solution. In fact, there's infinite solutions. Infinite means that it goes on for. Infinite means it goes on forever. Infinite solutions. So that means if I had x is less than 3, there's an infinite possibilities of what x could be. It could be literally any number you can think of that's smaller than 3. All right, so before we start solving inequalities, there's a special rule you have to know. It's super important. Whenever you multiply or divide by a negative number, you must flip the inequality sign. So what do I mean by that? So if I was going to solve this inequality over here, I know I have to get that x by itself. And I know a number next to x means that it's multiply. So to the opposite of that would be divide. So I would have to divide by -4 to get rid of that 4 on that side and leave me with x. And whatever I do to one side, I have to do to the other side to keep it balanced. So then I would do 16 divided by -4. And 16 divided by -4 is -4. So what do I mean by flipping? Well, you see the original sign was greater than, right? It was -4x is greater than 16. So I have to flip it. So the opposite of greater than is less than. So my final answer would be x is less than -4. And I can show that on my number line here by putting my numbers on my number line, and then I put a circle above -4, and now my final answer is x is less than -4, so I can draw my arrow to the numbers that are less than -4. And this is my graph for my final solution. Alright, so now that we have the basis of inequalities, let's go ahead and solve some inequalities. So these are examples of two-step inequalities. So two-step inequalities means there's two steps to solve to get that variable by itself. So this says 3x plus 5 is greater than 26. So I want to get that x by itself. So I like to draw a line to separate my two sides of my inequality. And then I see I want to get x by itself, so I need to get rid of this plus 5. I always do the opposite to get rid of something. So I know that the opposite of plus is minus. So I'm going to do a -5 to get rid of the 5 on that side. And I have to do the same thing to the other side to keep it balanced. And 26 minus 5 is 21. And then on my left side, I'm still left with that 3x. We didn't change this 3x, so we just bring it down. Now I want to get this x by itself, and I know a number next to a letter means multiply. So what's the opposite of multiply? Well, the opposite of multiplying something is dividing. So I divide by 3, and whatever I do to one side, I have to do the other side. So that leaves me with x, and 21 divided by 3 is 7. And I divided it by a positive, so my sign stays the same, right? And now I can put this on my number line. So I put 7, a number bigger, a number smaller, and then I'm going to put a circle on 7, and it says x is greater than 7. So I'm going to point my arrow towards numbers that are greater than 7. So this is my graph number line for my final answer. All right, let's try this next example. It's still a two-step equation, but it's a little different. All right, so I still want to get this x by itself. So I want to get rid of this number that's not next to the x first. So I look in front and I see there's nothing there. So that means this is a positive 7. So I think to myself, what's the opposite of a positive 7? Well, the opposite of positive 7 is -7. So whatever I do to one side, I have to do to the other side. So I put -7 on the other side. And that gets rid of that 7 on that side and leaves me with -4x, which I got from right here. It just comes straight down. And now on the side over here, I can do 19 minus 7, which is 12. Now I still want to get that x by itself, and I know that a number next to a letter means multiply, so I have to divide to get rid of that -4. So I'm going to do -4 divided by -4 cancels out and leaves me with x. And I have to do the same thing to the other side to keep it balanced. 12 divided by -4 is -3. All right, but I divided it by a negative. Remember my special rule, when you divide by negative, you got to flip your sign. So my original sign was greater than or equal to. So that means I have to flip that. The opposite of greater than or equal to is less than or equal to. And now that is my final answer. X is less than or equal to -3. So now I can put that on my number line. So I can put some numbers down here. I put my circle on -3. It's less than or equal to. So since it's equal to, we fill it in. And less than means we point the arrow to the numbers that are less than that. So this is my graph number line for my final answer. All right, let's try a little bit harder inequalities to solve. These are kind of like the equations that we did. They're the same steps as equations, except for our special rule. All right, so I look at this, and I see I have parentheses. So how do we get rid of parentheses in math? Well, the way we do that is, remember, we learned the distributive property. So you take that number on the outside, the 4, and you multiply it by both things on the inside. So 4 times k is 4k. 4 times 3 is 12. And then I can bring down everything else. And now I can make my line to separate my two sides of my inequality. So I still want to get that k by itself. So I want to get this k by itself. So I'm going to get rid of this 12, and I see this is plus 12, so the opposite of plus is minus. So I'm going to do minus 12. And that gets rid of the 12 on this side. And I have to do the same thing to the other side. 24 minus 12 is 12. And I'm still left with this 4k here, so I can bring that down. 4k. So I know a number next to a letter means multiply, so I have to divide to get rid of that 4. And that will leave me with k. And whatever I do to one side, I have to do to the other side. 12 divided by 4 is 3. And I divided it by a positive, so my sign stays the same. So this would be k is less than or equal to 3. So I can put that on my number line. 3, I'll put a number that's bigger, a number that's smaller, and it says k is less than or equal to, so I'm going to put a circle on 3, and it's equal to, so I can fill it in. And since it's less than, I point to the numbers that are smaller than 3. So this is my graph number line for my final answer. All right, let's do this next one over here. So this one even looks a little bit more complicated, but you can do it. Don't worry. Just follow the steps. So I see I have parentheses. So my first step when I have parentheses, I know I have to do distributive property. So negative 2 times x is negative 2x. And then I have to take negative 2 and times it by the other part. 2. Negative 2 times 2 is negative 4. And now I can bring everything else down since I got rid of my parentheses. All right, so now I can solve this equation. I look at this and I see I have an x here and an x here. Well, remember, we can combine our like terms. Any x's we can combine. So I have these two x's, I can combine these two. So negative 2x minus 2x would give me negative 4x. And now I'm still left with this negative 4, so I can bring that down. And I still have the 14 on this side over here. Now I'm left with a two-step equation, or two-step inequality, sorry. So I want to get rid of this minus 4, so I can do plus 4. And that plus 4 cancels out this 4 and leaves me with this negative 4x. And on the other side, I have 14 plus 4, and 14 plus 4 is 18. Now I have one last step. I know a number next to a letter means multiply, so I have to divide. So I'm going to divide by negative 4 to get rid of that negative 4 and leave me with x. And I'm going to divide this side by negative 4. 18 divided by negative 4 is negative 4.5. So now I have to look, since I divided it by a negative, I know I have to flip my sign. So my original sign was greater than or equal to. So I have to flip that, and the opposite of greater than or equal to is less than or equal to. So now I can put that on my number line. So let's put that on our number line. We have negative 4.5 in the middle. I put a number that's small or bigger than that, so negative 4, and a number that's smaller than that, negative 5. I'm going to put a circle above negative 4.5 because that was my answer, and it's less than or equal to, so I have to fill in my circle. And then since it's less than, I draw my arrow to point the numbers that are less than. So this is my graph number line for my final answer. So in conclusion, solving inequalities is just like solving equations. The only difference is when you divide by a negative, like we did in this situation, we have to make sure we flip our inequality sign. All right? And the other difference is when we can graph inequalities on a number line. And we show that by using arrows. So if it's less than, it gets pointed to the left. If it's greater than, it would get pointed to the right. All right. If you have any questions, please feel free to ask me anytime. You can email me or meet me in one of my office hours. All right. Have a great day.